All right, so let's go ahead and attempt to use this to find the area, or approximate the area, under the curve f of x equals x squared. Now we're going to be on the interval 0 to 2, and we're going to make 4 rectangles. That's where the n equals 4 is going to come in. All right, so first, delta x, that is our b minus a, so 2 minus 0 over 4. So the width of our rectangles is 1/2. Right, now for our points, we want to start at x naught, and that is going to be equal to a, which is 0. x1, x2, x3, x4. All right, and this is going to be b. We have 4 rectangles, so we'll go up to from 0 to 4. All right, so if we add by 1/2 here, we get 1/2, then 1, then 3/2. Now we want to find the function values at each of those. I'm going to evaluate x squared there, so that's 0. f of x1 is 1/4. f of x2 is 1. f of x3 is 9/4. So again, I am squaring those values because that is the function that I have. Because I have f of x equals x squared. And then f of x4 is 4. Alright, now L4, the area with 4 rectangles, is equal to the sum from I equals 0 to 3, based on the formula we have up there, f of xi times delta x. Now, this delta x is 1/2, so we can actually factor 1/2 out of there, 0 to 3, f of xi. So, L4 is going to be equal to 1/2 times the sum of the function values from 0 to 3. The right hand, well, we'll worry about that when we get there. Let's sum those function values. So 0 plus 1/4 plus 1 plus 9/4. And that should be 1.75. So the area coming from the left is 1.75. Now the area from the right, I equals 1 to 4, f of xi delta x. Something very similar here. This will be 1/2, starting at 1 to 4, f of xi. So we're going to add the function values coming from the right. So for this, we are actually going to start here and start there. So from the right, we're going to go from b backwards and stop 1 before the end. For the left endpoints, we'll start at 0 and move 1 until the end, till the other end. So we'll add up those function values. So that is 1/4 plus 1 plus 9/4 plus 4. And that area is 3.75. Now, if you notice, there's a big gap between 1.75 and 3.75. So how do we know what the area is? We don't. We are approximating it. And the idea is that we might be able to modify this to make it more accurate. For the time being, all we have is that the right-hand sum with 4 rectangles is 3.75, and the left-hand sum with 4 rectangles is 1.75. Example 5. Find a lower sum for 10 minus x squared on 1 to 2 with 4 subintervals. I'm going to sketch what that function looks like so we can have an idea over the interval 1 to 2. It has a vertex of 0, 10, and it is decreasing to the right and increasing on the left. So from 1 to 2, this is the area we're concerned with. If you notice, this is a decreasing function. Right. So the lower sum is actually going to be coming from the right. So we have a lower function or the lower sum is Rn if it's decreasing. Alright, so let's go ahead and work this out. So a being x0 is 1. Oh, we need to know delta x. B minus a over n is 4, which that is going to be 1/4. So x1 is going to be 5/4. x2 is 6/4 or 3/2. 7/4 for x3. And that'd be 8/4 or 2, and that is our b value. Now our function values, 10 minus x squared, so the first is 9. F of x1 is 8.4375. F of x2 is 7.75. F of x3 is 6.9375. And f of x4 is 6. So again, we're evaluating the function 10 minus x squared at each of these endpoints to get these function values. Now, and what we're going to sum is our function values. So in this problem, because we wanted the lower sum, what we're after is R4. That'll be the sum from 1 to 4, f of xi delta x, which will be 1/4. I equals 1 to 4 of our function values f of xi. So starting at 1 and going to 4, 8.4375 plus 7.75, 6.9375, plus 6. Finding 1/4 of that, that is 7.28125. And that is our lower sum. Keep thinking, how could we possibly make this estimate better? All right, find the lower sum of the function f of x equals sine x over the interval 0 to pi over 2. Based on what we know about sine, from 0 to pi, it's greater than 0, and from pi to 2 pi, it's less than 0. So pi over 2 is this region, so we're finding that area. Because it is increasing, the left-hand sums are going to be the lower sum. So let's start with x0. That's our a value. That is 0. And our delta x, we need that to find the next function value. That would be pi over 2 minus 0 over 6, which is pi 12ths. So x1 is pi 12ths. x2 is 2 pi 12ths, so pi over 6. That would be 3 pi 12ths, which would be pi over 4. We have 6 intervals. So, but once we hit pi over 2, we know we're there. That would be 4 pi 12ths, so pi thirds, 5 pi 12ths, and 6 pi 12ths, or pi over 2. So there is our last endpoint. Now, I am not going to actually evaluate these. We have sine of 0, sine of pi 12ths, f of x2, sine of pi 6ths. Okay. Sine of pi 4ths, is that output value there? F of x5 is sine of 5 pi over 12. And because we're doing a left-hand sum, we actually don't need that last function value. Alright, but that is going to be 1 there. Alright, so our L6, our lower sum with 6 rectangles, I equals 1, nope, starting at 0, going to 5, f of xi, delta x. Our delta x is pi 12ths. So the sum from 0 to 5 is sine of 0 plus sine of pi 12ths plus sine of pi 6ths plus sine of pi 4ths plus sine of pi 3rds sine of 5 pi 12ths. And that sum will be approximately 0.863. So there's my approximate